Hello, so our topic for today is intermediate SQL, and it will cover the selection of data, querying database, learning to count, practice with counts, select listing, and so on and so forth. This is a four-hour lesson, and we'll try to cover the entire course in one sitting, in one session.
Hello, my name is Yasmin Ludolf, and I'll be your instructor for this course on using SQL to turn raw data into actionable insights. We'll build on our foundational knowledge of SQL, learn how to reveal insights, and how to present our results clearly. While SQL can be used to create and modify databases, the focus of this course will be querying databases. Recall that a query is a request for data from a database. In this course, we'll look at how to execute a query for a database using keywords that will enable us to count and view all or a specified amount of records. We'll go over common SQL errors, style guidelines, and the order in which our code will execute. We'll cover how to filter data using various techniques, how to use aggregate functions, and finally, how to sort and group the results. We'll be using PostgreSQL throughout. We will work with a films database containing 4 tables: films, reviews, people, and roles. Our database schema, pictured here, shows the table names, field names, and data types. Here we go with our first new keyword. Let's say we wanted to count something from our people table. The count function lets us do this by returning the number of records with a value in a field. For example, to count the number of birth dates present in the people table, we will use select count birth date from people. The result is 6,152 birth dates. We've used the alias count birth dates for the field name in this example to make the results more readable. If we want to count more than one field, we need to use count multiple times. Here we are counting both the number of names and birth dates present in the people table. Using count with a field name tells us how many values are in a field. However, if we want to count the number of records in a table, we can call count with an asterisk. For example, this code gives the total number of records in the people table. The asterisk represents all fields. Passing the asterisk to count is a shortcut for counting the total number of records. Often our results will include duplicates. We can use the distinct keyword to select all the unique values from a field. This might be useful if, for example, we're interested in knowing which languages are represented in the films table. Adding distinct to our query will remove all duplicates, as we can see here. Combining count with distinct is also common to count the number of unique values in a field. This query counts the number of distinct birth dates in the people table. Let's take a moment to consider why this number is different from the birth date count of 6,152 we got before. Some people in our table likely share the same birthday. Count would include all the duplicates, while distinct counts all of the unique dates, no matter how many times they come up. Now, let's practice counting.
Okay, so the first lesson is learning how to count in SQL. By the way, those who do not know what SQL is, it's SQL or SQL is structured query language. We use it for getting data or manipulating data within the database. So it says you're learning to count. Use the function count or the aggregate function count. Says that we saw how to use the count in the video. So let's see what it returns. Here is a query counting film ID. Film ID, as usual, the tabs are here were the table names. And if we click on the tabs of the tables, we'll see the structures. The structures are the columns or the fields or the columns of each table, the columns and the rows. So for the fields, it has an ID, the title, the release year, the country, duration, language, certification, gross, and budget. Then for the people table, we have ID, name, birth date, and that date. Then the reviews has ID, film ID, num user, num critic, IMDb score, num votes, Facebook likes, and Facebook likes. And for the rows table, we have ID, film ID, person ID, and role. So for the instructions, select the answer below that correctly describes what the query will return. So the query is select count film ID as count film ID from reviews. So let's see the reviews table. Here's the reviews table. Then we have to run the query. Count. We just copied the statement from the left panel. The right panel here is the GUI or the user interface, and we have to run the code and see what it will return. So it returns the number of film IDs, which is 4,968. So for the answer, the number of records containing the total number of records with select count film ID. So the number of records count film ID from reviews. It's the sum of the film ID field. Because when we say the number of records here is says here 4,968 rows. Oh, wait. Count film ID as count film ID from reviews. So the number of records containing a film ID. The sum of the film ID fields. No, it's not the sum of the film ID fields. It's the number of records containing a film ID because it has 4,968 rows and it returned a value of 4,968. Okay. Hi, hello. Thank you for dropping by. Can I poke you? Okay, let's continue with the lesson. Thank you so much. Then let's continue. Now we have to practice with count. So as we've seen, count asterisk tells us how many records are in a table. However, if you want to count the number of non-missing values in a particular field, we can call count on just that field. Count asterisk tells us how many records are in a table. However, if we want to count the number of non-missing values, okay, if we have to have a particular count on a particular field, so let's have to get some practice with count. We can look at the data in the tables throughout this exercise by clicking on the table names in the console. This is the table names. This part here is the console, and these are the table names. So the tables available here are films and people. Films and people. And for the instructions, it says here that count the number of records in the people table, aliasing the result as count records. So this is the people table. So we have to count the number of records. To count the number of records, have to how do we count the number of records? Select count asterisk from. Hello, thank you so much. Thank you. Thank you for the house plant. So many house plants. I'm sorry, I cannot read your read your name because I don't know how to read foreign alphabet. I can just poke you because I cannot read your name. Thank you so much. From people table, aliasing the result. So count asterisk as. To alias a column, we have to use the word as. Then the alias name. Count records. Then let's try to run the code and submit the answer. Count the number of records in the people table, aliasing the result as count records. So we have to submit the answer. Then after that, count the number of records with the birth date in the people table. So the first one we counted the number of records, the total number of records. And then now we're going to have a particular with the birth date. So Let's check on the structure of the people table. It has a birth date. So we have to select and count birth date. Birth date. Birth date. Birth date. As count birth date. From the people table. And count the number of records with the birth date in the people table, aliasing the result as count underscore birth date. So select count birth date as count underscore birth date from people. Then let's run the code just to check if it generated the result, and then submit the answer. So for the previous one, we counted all the records. Then the next one, we were counting particularly the birth date. Then for the next instruction, thank you so much. For the next instruction, count the languages and the countries in the film. Languages and countries in the films table, alias as count languages and count countries. So from the films table, let's see the structure of the films table. So the films table has languages. It says languages, the language column, and the country. Where is that? The country column. Okay, so we have to count the languages in the country column from the table films. So we have to select count language as count languages and count country. From the films. Okay, so let's review our code and then count the languages and countries as from the films table, alias it as count languages and count countries. Okay. We have to be specific. We have to follow the instructions. So count countries, and then let's run the code and submit the answer. So it returns the result of count languages, which is 4,957, and the number of countries, which is 4,966. So submit the answer. Yay! Stress bien. What's stress bien? Okay. So looking at the difference between the count of unique values, total values, and all records can provide useful insights into the data. Okay. So now for the select distinct. We have to use distinct if we want to get the unique, to return the unique values, to avoid multiple, how do you call that? Multiple recurrence. Okay, so with the select distinct, it says here that often query results will include many duplicate values. Then we can use the distinct keyword to select the unique values from a field. And it might be useful if, for example, you're interested in knowing which languages are present in the films table. So to see if we can find out what countries are represented in this table with the following exercises. So here it's only the films table, okay? Then loading the data for the films table as title, ID, release year, country, duration, language, certification, gross, and budget. Then for the instructions, return the unique countries represented in the films table using distinct. The unique countries. So we have to select no, it doesn't say that we have to count the country. We just have to return the distinct. Yes, we have to count nga because these are the number of unique. So with the number base, with the root word number, it has to be the count. Use the function count. Country from the films table. It's just the sole table here. So you return the unique countries. Sorry. The count will be used on the second instruction. For the first, it just says that we have to return the unique countries, so we don't have to use the count. My eye is wandering on the second statement, on the second instruction. So it says here that return the unique countries represented in the films table using distinct. So we have to use the select distinct country from films. Then let's run the code. So it shows 65 out of. Let's see if it doesn't have then for the next statement we have to. This is where the count. You have to use the count word. Select distinct. Count. Yay, thank you. Select count. Oops, sorry. Count distinct countries. Count distinct countries from the table films. So it says here that return the number of unique countries represented in the films table alias as count distinct countries. So we have to select distinct to use the distinct to return the unique values, and then for the number of unique countries you have to distinct count country, then we have to alias it as count distinct countries, then we gather it from the table films. So we have to run the code and then submit the answer. Check the highlighted code. What's the highlighted code? The country. Count country. Wait. Return the number of unique countries. Country. Could not find the first entry in the preference. Return the number of unique country count. Okay. But still we can count the number of countries. Select distinct the count number of unique countries represented in the films table. Hi, hello, thank you so much for liking the streamer. What could be the problem? Select distinct countries from the field. Count the distinct countries. Distinct countries. Could be the problem. You can combine count with distinct to count unique values. Continue learning. There are instances that I cannot. I think. Okay. So the problem is with the open and close parentheses. Distinct country. Okay. So. Let's try to run the code. 64. Okay. The answer before, I put the distinct before the count function, and it returns a value of 4,166. Whereas here it should be the count, the distinct should be placed inside the open and close parentheses of the function count, counting on the distinct country. So that's why it was my previous answer was wrong, because I put the distinct word outside of the function count. So I hope you can learn something from my mistakes. Okay, so let's run the solution. And then, okay, so using distinct is a great tool to see the unique values of a data set. This table has 64 unique countries. So
Fantastic work on using count and distinct. Now that we've flexed our SQL muscle a bit, we'll take a small step back and better understand how SQL code works. Unlike many programming languages, SQL code is not processed in the order it is written. Consider we want to grab a coat from a closet. First, we need to know which closet contains the coats. This is similar to the from statement, which is the first line to be processed. Before any data can be selected, the table from which the data will be selected needs to be indicated. Next, our selection is made. Finally, the results are refined. Here we use the limit keyword that limits the result to a specified number of records. In this case, we only want to return the first 10 names from the people table. Knowing processing order is especially useful when debugging and aliasing fields and tables. Suppose we need to refer to an alias later on in our code. In that case, that alias will only make sense to a processor when its declaration in the select statement is processed before the alias reference is made elsewhere in the query. Before we begin working with more advanced queries, it's useful to know more about debugging SQL code and how to read the error messages. Some messages are extremely helpful, pinpointing and even suggesting a solution for the error, as this message does when we misspell the name field we'd like to select. Other common errors may involve incorrect capitalization or punctuation. Other error messages are less helpful and require us to review our code more closely. Forgetting a comma is a very common error. Let's say we've drafted this code to find all titles, country of origin, and duration of films. The error message will alert us to the general location of the error using a caret below the line of code, which in this case points to the country field name. We must examine the code a little further though to discover the missing comma is between country and duration. SQL displays a similar error message when a keyword is misspelled, but this time the caret indicator below the offending line is spot on. There are a few more SQL errors out there, but the 3 mentioned in this lesson will be the most common ones we will encounter. Debugging is a major skill, and the best way to master this skill is to make mistakes and learn from them. Let's practice.
Okay. So she said that the best way to master the skill is by practicing. So we have to practice. So for the order of execution, every time I'm learning, every time I'm studying, it makes me sleepy. Okay, so for the execution, order of execution, so we first have to, it says here that SQL code is processed differently than other programming languages because in that we have to, that you need to let the processor know where to pull the data from before making selections. So it's essential to know your code's order of execution to understand what results you get from your query and how to fix any errors that may come up. So for the instructions, we have to drag the SQL keywords into the order that they will be executed in from first to the last. So we have to check. We have to, here, first is the select, and then the from, and then the limit. I have to submit the answer. What? From in the wrong place? executed in from first. Huh? From from is the source. So okay. So it's not asking for the sequence of how do we place the code, but instead the sequence on how do we gather the data. So this is the correct order of execution. So it says here the order of execution. What I did before was the order of how do we place the code or how do we place the commands. So it makes sense that SQL need to select data from a table before it can limit the results. So, okay. Can be confusing with instructions. So, for the debugging errors, debugging is an essential skill for all coders, and it comes from making many mistakes. So, as I've said before, it's okay to make mistakes as long as we realize or we analyze what our mistakes are and we learned how to correct them. So it says here, it comes from making many mistakes and learning from them. So in this exercise, we'll be given some buggy code that we'll have to fix. So for the instructions, debug and fix the SQL query provided. Select, debug this code. Select certification from films limit 5. This is the films table, and yes, it has a certification column. Yes, it has a certification column. So select certification from films limit 5. I think it's no need to. Column certification does not. Okay. It's missing the missing cert. The spelling is wrong. Okay. Okay. So then next, find the two errors in this code. The same error had been repeated twice. So no, the error here is the comma. We'll have to use the comma as a separator for when selecting the fields or the columns. Then first we have to check on the reviews table if these columns exist or the fields exist. So film ID, okay. IMDb underscore score, okay, and numvotes, okay, from reviews. So submit the answer. So okay, and then find the two bugs in this final query. The bugs here is 2, the count. So the count and the people column. I think those are the two bugs. The spelling of count and the spelling on people. Then we have to run the code and it returns the result. Then we have to submit the answer. Yay. says excellent extermination of those bugs. This is an important skill that will come in very handy. Hi, thank you for
Terrific
staying.
job! Now that we understand how SQL works, we'll review how it looks. SQL is a generous language when it comes to formatting. New lines, capitalization, and indentation are not required in SQL as they sometimes are in other programming languages. For example, the code here will run just fine, returning the first 3 titles, release years, and countries from the films table. However, writing queries like this won't make us any friends in the SQL world because the lack of formatting makes the code difficult to read, especially as queries become more complex. Over time, SQL users have developed style standards that are generally accepted across industries. This code returns the same results as the code on the previous slide, but it is much easier to read due to the addition of capitalized keywords and new lines between them. While keyword capitalization and new lines are standard practice, many of the finer details of SQL styles are not. For instance, some SQL users prefer to create a new line and indent each selected field when a query selects multiple fields, as the query on this slide does. Because of the different formatting styles, it's helpful to follow a SQL style guide, such as Hollywell's, which outlines a standard of best practices for indentation, capitalization, and naming conventions for tables, fields, and aliases. Remember, though, that there is no single required formatting in SQL. The guiding principle is writing clear and readable code. Have you noticed the sample code we've been looking at throughout this lesson has a semicolon at the end? Like capitalization and new lines, this semicolon is unnecessary in PostgreSQL. We could leave it out of the query and still expect the same results with no errors. However, including a semicolon at the end of the query is considered best practice for several reasons. First, some SQL flavors require it, so it's a good habit to have. Including a semicolon in a PostgreSQL query means that the query is more easily translated to another flavor if necessary. Additionally, like a period at the end of a sentence, a semicolon at the end of a query indicates its end, which is helpful in a file containing several queries. One last note on SQL style. While we can ensure our code is formatted beautifully, we don't have control over other people's SQL style. When creating a table, a SQL mistake is including spaces in a field name. To query that table, we'll need to enclose the field name in double quotes to indicate that, despite being 2 words, the name refers to just one field. For example, if a sloppy SQL coder had named a field release space year as 2 words, we'd need to update the query we've seen throughout this chapter to the one shown here. Adhering to SQL style guides allows for easier collaboration between peers. Having clean and readable code is highly valued in the community and a professional setting, and will make things easier for anyone wanting to understand or debug our queries. Let's try it out.
So for the SQL best practices, it says here that SQL style guides outline standard best practices for writing code. So this exercise will present several SQL style tips. Our job will be to decide whether they are considered best practices. So for the instructions, we'll have to drag and drop the items into the correct zone. Right, lots of queries with no semicolon. although it's easier that on some SQL flavors it can run, but for the best practice it should be with semicolon, so that it will run on all SQL flavors, and end queries with a semicolon. Yes, okay. Excuse. So it's easier that well done. You'll soon become everyone's favorite SQL programmer. Yes. I hope this is true. This can be true. So you have to rewrite the query. Formatting. Readable code is highly valued in the coding community and professional settings. Then without proper formatting, code and results can be difficult to interpret. We'll often be working with other people that need to understand our code or to be able to explain our results. So having a solid formatting habit is essential. So in this exercise, we'll correct poorly written code to better adhere to SQL style standards. So adjust the sample code so that it is in line with standard practices. So we have to rewrite the query. To rewrite the query, have to capitalize. Have to capitalize on the keywords. So the keywords here are select and row from. Oops, sorry again. My the wirings on my mic is very sensitive. I'm using a condenser mic, that's why. Okay, so the keywords are select, from, and limit. So we have to capitalize the keywords, and then we have to place the semicolon at the end of each statement. Wait, I haven't checked columns. Okay, select person ID, then role from roles. Limit 10. Don't forget the final punctuation too. But I've placed here a punctuation. Do I have to place a space in between? It's easier than standard practice to capitalize keywords and create new lines. Create new lines. What could be? New lines. So for every keyword, we have to uh, press on the return key or the enter. So it says here that we may occasionally receive a dataset with poorly named fields. Ideally, you would fix these, but you can work around it with some added punctuation in this instance. Ay, how can I finish this in 4 hours when I haven't been streaming in an hour and I'm already sleepy? Ay. Okay, so for non-standard fields, we may occasionally receive it set with a poorly named fields. Ideally, we have to fix this, but we can also work around with some added punctuation in this instance. For example, query and schema. A sample query and a schema have been provided. Imagine that we need to be able to run it in a non-standard field name. Then select the multiple choice answer that would correctly fill in the blank to return both a film's ID and its number of Facebook likes for all reviews. So the instruction, the code here is select film ID and then space from reviews. What's the question? Again, imagine we have to be able to run a non-standard field name. Select the multiple choice answer to correctly fill in the blank to return both a film's ID and the number of Facebook likes for all reviews. Okay, so it says here that using double quotes around a non-standard name allows us to run the SQL query. So, good job. And we finished the chapter. How many chapters do we have to?
Welcome back. Now that we've mastered selecting and counting data from a database, we'll add to our repertoire by learning
Four
about
chapters,
filtering.
and we're on the
To
second.
filter, we need to use a new clause called where, which allows us to focus on only the data relevant to our business questions. Going back to our coat analogy, we may want to select a coat from the closet where the color is green. The where clause can help us with that. We will focus on filtering numbers in this lesson. To do this, we will be using comparison operators such as greater than. Here is an example of a query where we filtered to see only films released after the year 1960 using the greater than operator. Let's explore some of the other operators. We would use the less than operator to see films released before the year 1960. We would use the less than or equal to operator to see films released during or before the year 1960. If we want to see films released in a specific year, we can use equals. Here is a final example that isn't as intuitive as the others. If we wanted to filter films to see all releases except those from the year 1960, we would combine the less than and greater than symbols as shown here. This is the SQL standard symbol that means not equal to. Let's recap all the comparison operators we can use with where to filter numbers. We have greater than, that also means after, less than, that also means before, equal to, greater than or equal to, less than or equal to, and not equal to. Where and the comparison operator equals can also be used with strings. In these cases, we will have to use single quotation marks around the strings we want to filter. For example, here we want to filter titles where the country is Japan. A final note on using where. Similar to limit, this clause comes after the from statement when writing a query. If we were to use both where and limit, the written order will be select, from, where, limit. However, the order of execution will now be from, where, select, limit. Thinking about the coats in our closet, we go to the closet we want to get the coat from, find where the green coats are, and select 5 of them. Okay, now it's time for practice.
Sorry again. So for the filtering results, the where clause allows us to filter based on text and numeric values in a table using comparison operators. So what does the following query return? I have watery eyes. So the query here says select title from films where release year is greater than 2000. So it will return all the films released after the year 2000. So because before should be less than, and it says you're greater than, then greater than, and greater than. So submit the answer. Okay, it's correct. Then using where with numbers. We use where for filtering data. So okay, so now we are on filtering records. The first chapter was selecting data, and now we're on filtering records. Then after that, we have the aggregate functions and the sorting and grouping. Okay, I hope we can tackle all these on one sitting. Then using where with numbers. Filtering with where allows us to analyze our data better. Then we may have a data set that includes a range of different movies, and we need to do a case study on the most notable films with the biggest budgets. In this case, we want to filter our data to a specific budget range. So now it's our turn to use the where clause to filter numeric values. So we have to do the select the film ID and IMDb score from the reviews table and filter on scores higher than 7.0. So we have to select film ID. Why? I'm not sure. Sorry, I have to. Hello, hello, mic test hello. Hello, 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 mic test hello, testing 1, 2, 3, hello. Okay. So we have to select the film ID. This is the reviews table, and it has the film ID and the IMDb score. Then we have to where clause to get only the scores higher than 7. So where I am greater than 7. Then again, we have to select the film and Facebook likes of the first 10 records with less than 1,000 likes from the reviews table. So we have to select check on the reviews structure again, and it says your Facebook underscore likes. So it says here that we have to select the film ID and the Facebook likes of the first 10. So for the first 10, we have to, no, it's not limit. I think it's stop. Again, having confusions. Is the limit and top the same? Let's see. Anyway, if this returns an error, it means that so near top. So the top is not a. Just have to use the word limit. Okay, so says you that we have to select film ID and Facebook likes of the first 10 records with less than 1,000 likes from the reviews table. So select film ID, Facebook likes from reviews where Facebook likes less than 1,000, limit 10. Then we have to submit the answer. Then count the records with at least 100,000 votes. Votes. What's the votes? Number of votes. This is the column for the votes. Okay, it says you're well then applying a where filter with a SQL is much easier and faster than scrolling through a spreadsheet or using a highlighter. Okay, so using where with text. Where can also filter string values. Before we use it with numeric values, but now we have to use it with string values. So imagine we are part of an organization that gives cinematography awards, and we have several international categories. Before we confirm an award for every language listed in our data set, it may be worth seeing if there are enough films of a specific language to make it a fair competition. If there is only one movie or a significant skew, it may be worth considering a different way of giving international awards. So let's try this out. init. It's very hot. It's already summer here in the Philippines and it's so hot. The weather is hot. So for the select and count the language fields using the alias count Spanish. Okay. Select and count the language field used using the alias count Spanish. So let's check again the films table and I've turned on the fan because it's very hot. But the fan is wait. The fan is affecting the microphone. But I cannot bear it because it's very hot. And my aircon is working only on a fan mode, so I have to turn it off. I have to clamp my hair because it's very hot. Still see. Hello, Mike Costello, testing 1, 2, 3, hello. I hope we can still go on with the but the fan really is distracting. How do I do this? I have 3 fans at the front, at the side, and at the at the at the back. I'm using 3 fans because it's really hot. And the aircon it's working, but it's working also on a fan mode. Maybe it's because it's the summer season. So, okay, let's see. So we have to select and count the language field using the alias count Spanish. Press the column language. Okay. Select and count the language field using the alias count Spanish. Apply a filter to select only Spanish from the language field. Okay, so this is the filter where language was Spanish. Then we have to run the code. It says here that my output generated an error, and the error should it says here that films that language must appear in the group by clause or can be used in an aggregate function why we just selected the language. Select language. Then count language as count Spanish. Okay, there are 40 Spanish language films in this table. Okay.
Great work on filtering numbers. Our SQL skills are growing fast. Next up, we will look at how to filter with multiple criteria. There will often be the case that we have more than one criteria we'd like to meet. Looking again at our favorite coats, perhaps we want to narrow down our choices to coats that are yellow and shorter in length. We will be learning about 3 additional keywords that will allow us to enhance our filters when using where by adding multiple criteria. These are or, and between. In the context of our coats, we could look at coats where the color is yellow or the length is short. Or we could filter for coats where both criteria are true. We can also look for coats that have between 1 and 5 buttons. The first keyword we will look at is the OR operator. OR is used when we want to filter multiple criteria and only need to satisfy at least one condition. Perhaps we want to select green or purple code options as an example. In SQL, we combine OR with where to achieve this type of filtering. Here is an example using the films database. The query on the left returns all films released in either 1994 or 2000. Note that we must specify the field for every OR condition. So the query on the right specify the field for every OR condition. So the query on the right specify the field for every OR condition. So the query on the right specify the field for every OR condition. So the query on the right specify the is invalid. That query hasn't specified what field or operator should be associated with the year 2000. If we want to satisfy all criteria in our filter, we need to use AND with where. For example, this query gives us the titles of films released between 1994 and 2000. We need to specify the field name separately for every AND condition as with OR. Let's kick it up a notch. We now want to filter films released in 1994 or 1995 and with a certification of either PG or R. Thankfully, we can combine and or to answer this question. If a query has multiple filtering conditions, we will need to enclose the individual clauses in parentheses to ensure the correct execution order. Otherwise, we may not get the expected results. As we've learned, we can use this query to get titles of all films released in and between 1994 and 2000. Checking for ranges like this is very common, so in SQL, the between keyword provides a valuable shorthand for filtering values within a specified range. This second query is equivalent to the one on the left. It's important to remember that between is inclusive, meaning the results contain the beginning and end values. Like the where clause, the between clause can be used with multiple and or operators, so we can build up our queries and make them even more powerful. For example, we can get the titles of all films released between 1994 and 2000 from the United Kingdom. Have a go at using between, and or on the films database.
So, moving on, using and. The following exercises combine and or with the where clause. Using these operators together strengthens our queries and analysis of data. So we will have to apply these new skills on the films database. So for the instructions, it says here that we have to select the title and release year for all German language films released before 2000. So let's look again on the structure and see what the table has, the content of the table, what are the rows and columns. So we have to select the title and the release year. Released before, release year before is less than, and German language. So it says here that we have to select the title and release year for all German language films released before 2000. So where release date is less than 2000 and language equals German. So it shows it returns 6 rows. Then we have to submit the answer. Oh, 2 more hours to go. I hope I can finish this in time. Then update the query from previous step to show German language films released after rather than before. So we just have to change this for German language films released after rather than before. Then for the third instruction, we have to select all details of German language films released after. Using only were and were German and after 2000. Oh. Says here that select all details of for German language films. So language. I think I have a wrong spelling here. Language. So we have to be mindful of our typo errors. Language and release year is released after, so greater than 2000, but before, so greater than 2000 and less than 2010, using only were and. So we have to just choose the keywords were and. So after running the code, it shows 9 rows, and we have to submit the answer. Says repeat or combining conditions with AND will prove to be very useful when we want our query to return a specific subset of records. Then using OR, this time we'll write our query to get the title and release year or films released in 1990 or 1991, which were in English or Spanish and took in more than $2 million gross. Says here that looks a lot, but you can build the query up one step up at a time to get comfortable with the underlying concept in each step. So let's go. So for the first instruction, select the title and release year for films. Because it's very hot. Title and release year from films where or issue. So it says here that we have to select the title and release year for films. So select title release year from films for films released in 1990 or 1999 using only were and or. So then after After that, filter the records to only include English or Spanish language films. So we have to add a filter. Then finally, restrict the query to only return films worth more than $2 million. So to do that, we have to add an additional condition. So we can check on the structure, so gross. More than, so it's greater than. Wait. 1, 2, 3, 1, 2, 3, okay. Yay, amazing work. So some of these queries were pretty complex. Okay. But then we have to use the between, using between. Then let's use between with, let's choose between with and. Let's choose between with and on the between with and on the films database to get the title and release year of all Spanish language films. Replaced between 1990 and 2000 inclusive with the budgets over $100 million. We have broken the problem to smaller steps so that we can build the query as we get along. So for the instructions, we have for instructions here, it says here select the title and year of all films released between 1990 and 2000, inclusive using between. Select title. This year of all films from Then we have to narrow down our query to the films with budget over $100 million. See again the columns. What are the columns and the budget? It says budget. where it should be greater than, then 100, 1, 100, 1, 2, 3, 1, 2, 3. Okay. Then let's run the code, and it shows 28 rows. Then submit the answer. Then for the third instruction, we have to restrict the query to only Spanish language films. So we have to add an additional condition, and language. No. And the language. Spanish. Between and budget and language. Then we have to run the code, then submit the answer. It only shows one record. Now we have to finally to amend the query to include all Spanish language or French language with films with the same criteria. So we just have to same criteria. So we just have to or place an or. Language equals Spanish or language equals, what's the French? Okay, I think I've done this before, but I don't know why datacamp or maybe it was from another instructor, but also here in datacamp. I've done this module before, but it was not credited on the career track. So I'm doing this again, so that for the certification track for the data analyst in SQL track, I have to take this course under this instructor or under this particular module. So we have to submit the answer, and okay. So using where with the combination of and, or, and between is an efficient way to query a desired range of values. Okay. So to continue,
we're making excellent progress.
methods.
We will now switch our focus away from filtering numbers to filtering textual data. As we've briefly seen, we can use the where clause to filter text data. However, so far, we've only been able to filter by specifying the exact text we're interested in. We'll often want to search for a pattern rather than a specific text string in the real world. We'll be introducing 3 more SQL keywords into our vocabulary to help us achieve this: like, not like, and in. In SQL, we can use the like operator with the where clause to search for a pattern in a field. We use a wildcard as a placeholder for some other values to accomplish this. There are 2 wildcards with like, the % and the underscore. The % wildcard will match 0, 1, or many characters in the text. For example, the query on the left matches people like Adele, Adelaide, and Aiden. The underscore wildcard will match a single character. For example, the query on the right matches only 3-letter names like Eve. We'd also see names like Eva if it were in our dataset. Eva Mendes, however, would not be visible unless the search criteria looked like this. We can also use the not like operator to find records that don't match the specified pattern. In this query, we are finding records for people who do not have a dot as part of their first name. It's important to note that this operation is case sensitive, so we must be mindful of what we are querying. We've reviewed one example of where to position each wildcard, but we can actually put them anywhere and combine them. We can find values that start, end, or contain characters in any position, as well as find records of a certain length. For example, this code on the left will find all people whose name ends in R. The code on the right will find records where the third character is T. What if we want to filter based on many conditions or a range of numbers? We could change several ORs to the where clause based on what we know, but that can get messy. We can see an example here where we select the film titles released in 1920, 1930, or 1940. A helpful operator here is in. The in operator allows us to specify multiple values in a where clause, making it easier and quicker to set numerous OR conditions. Neat, right? So, the example shown on the previous slide would simply become where release year in 1920, 1930, 1940, where the years are enclosed in parentheses. Here is another example using a text field where we want to find the title where the associated country is either Germany or France. Let's practice.
I'm gonna finish this course in one sitting because I'm already sleepy. Okay, so using the not like and not like. The like and not like operators can be used to find records that either match or do not match a specified pattern, respectively. They can be coupled with the wildcards and the underscore, with the wildcards percentage and the underscore. The percentage will match 0 or any characters, and the underscore will match a single character. So this is useful when we want to filter text, but not to an exact word. So do the following exercises to gain some practice with these keywords. Okay. So for the instructions, select the names of all people whose name begins with B. Let's just check the structure of the people. So the column is name. Then select the names of people whose names have R as the second letter. Then select the names of people. I'm really getting sleepy. I think I'll just do this in two parts. Let me see. I still have 1, 2, 3, 4, 5, 6 topics until we finish this. chapter. This- Or is the second letter? Ano ba? There is, okay, I think this is it. Okay, then select the names of people whose names don't start with A. Hmm? Okay, it says here that we're making a progress. Filtering our data to find specific patterns is vital to our skill set. skill. Our results still had names that started with A with an accent. Yes, it has an accent. Showing that we need to be specific with our filtering criteria. Okay. With data, we always have to be specific. One, one wrong, one wrong character gives a different result. So we're in. Now we know we can query multiple conditions using the in operator and a set of parentheses. It is a valuable piece of code that helps us keep our queries clean and concise. Then try using the in operator. We have to use the in operator. For the instructions, select the title and release year of all films released in 1990 or 2000 that were longer than 2 hours. So again, we have to check on the structure of the table, and we have to return the title and the release year of all films released between in 1990 or 2000 that were longer than. So for the longer than 2 hours, we have to check on the duration. I think the duration here is in minutes. So longer than 2 hours should be 120 minutes, because we have to use the conversion of an hour into minutes. So it says you find the title and release year for all films. Duration. So, since the topic, our topic right here is on the using the were in, we have to use the were in. We can also use the release year using the or operator, but since the topic is in were in, we have to use the were in with our query. So says you that select title and release year of all films released in 1990 or 2000 that were longer than 2 hours. Then find the title and language of all films in English, Spanish, and French. Then select the title and certification and language of all films certified NC-17 or R that are in English, Italian, or Greek. Since no one is sharing my my stream, I have to do it myself. Thank you for my friends who are staying accompanying me with with my learning module. What is this? poll. Have I created a poll? Let's just say that. Okay, so it says here that select title, certification, and language. Certification, what's the column for the certification? Is it really certification, title, certification, and the language? For all fields, title. This is 17. It's difficult because I have my mic is my mic is placed just above my keyboard, so I'm having trouble typing because once touch I've touched on the mic's wire, it's it's getting sensitive. In English, Italian. I hope this is correct. Yay! Our SQL vocabulary is growing by the minute. A Fistful of Dollars starring Clint Eastwood is listed as Italian. So, hello, Penny. Thank you. Can I poke you? I hope you're still in here. Thank you so much for dropping by. So, let's continue with our lesson. So, for the combining filtering and selecting, let's check on the 74%. So we still have we still have 1, 2, 3, and 4 lessons to take before I made it halfway. I started around 3 o'clock and it's now almost 5 o'clock. More than 2 hours already. Oh, it says here that this. I think I started around before 3. Okay, so let's just move on. Okay. Combining filtering and selecting. Time for a little challenge. I think what I'm doing here is just the basics with the real life scenario. We have to gather data from all sorts of and all sorts of sources, and also we have to create so different outputs. So what I'm discussing here is just the basics. But as we go, as we practice, it makes us more adept to the language. So let's just move on. Okay, time for the challenge. So far, our SQL vocabulary from this course includes count, distinct, limit, where, or, and, between, like, not like, and in. In this exercise, we'll have to try to use some of these together. Writing more complex queries will be standard for you, for us, as we become qualified SQL programmer. So as this query will be a little more complicated than what we've seen so far, we've included a bit of code to get us started. We'll be using distinct here too because surprise, there are 2 movies named Hamlet in this dataset. Following the instructions to find out what 90s films we have in our dataset that would be suitable for English-speaking teens. So for the instructions, count the unique titles from the films database and use the alias provided. So once again, we have to count. It says distinct. This is my distinct count, distinct titles. Okay, the column name is title. Count, distinct, titles, 90s, English films for teens, from films were filtered to release years between. Where release year is between $19.99. Okay, then we have to filter the English language films. Okay, let's check on the filter to include only movies with the release year from 1992, 1995, 1999 inclusive. Then add another filter, now narrowing our query down to English language films. So we have to use the and language equals English. Then again, we have to narrow it down to and certification in PG 13. Okay, let's check if it's the final filter to select only films with GPG PG-13 certifications. Let's double check on the certification. certification. Okay, certification. Then run the code and submit the answer. Yay! Says it that we have a natural flair for filtering. So this filter tells us we have 310 fields that the 90s obsessed teenagers can enjoy. But now, I'm not a 90s teenager.
Our next lesson will review how to filter data that includes null values. When we were learning how to use the count keyword, we learned that we could include or exclude non-missing values depending on whether or not we use the asterisk in our query. But what is a missing or non-missing value? In SQL, null represents a missing or unknown value. Why is this useful? In the real world, our databases will likely have empty fields either because of human error or because the information is not available or is unknown. Knowing how to handle these fields is essential as they can affect any analyses we do. For example, we used count all with an asterisk on the left. Suppose our goal is to analyze posthumous success using data from the people table. We might make the wrong assumption that because we have a field name called death date, this information is available for everyone. Half of them are in fact null, as we can see on the right, so we would make an inaccurate judgment on what the data means. One quick way to see how much of our data is missing is by using isNull with the where clause. Here is an example where we have checked to see which names do not have a recorded birth date in our table. On the left is an example of counting the missing birth dates in the people table. The count is 2,245. Sometimes we'll want to filter out missing values, so we only get results that are not null. To do this, we can use the isNotNull operator. For example, this query on the right gives the count of all people whose birth dates are not missing in the people table, giving us a new count of 6,152. There may be a question about the difference between using count with a field name and using the same count with the added where clause with isNotNull. The answer is there is no difference, as both will be counting non-missing values. Before we wrap up this lesson, let's review what we've learned. Null values are missing values, and they are very common in the real world. It is good practice to know how many null values are in our data by using the isNull or isNotNull operator for filtering. These keywords will help to identify, select, or exclude missing values. Don't worry, this will soon become second nature because it is that common. That's a wrap. It's time for more practice.
So for the practice, we just have to answer the question that what does null represent? A missing value. Okay, so it says here correct. Null is used to represent unknown values. Then for our practice with null, for the instructions for the practice, select the title of every year that doesn't have a budget associated with it and use the alias no budget info. What is the also fields budget. Select title. Is this correct? Okay. Then count the number of films with a language associated with them and use the alias count language known. Count the number of films we have language data for. So we're okay, all right. That's 4,957 films and language of films with language data. We've mastered selecting and filtering data, which means we're halfway through the course. Okay, yes, we're halfway.
Fantastic job getting this far. Let's learn about summarizing data with aggregate functions. When analyzing data, we often want to understand the dataset as a whole, in addition to looking at individual records. One way to do this is to summarize the data using SQL's aggregate functions. An aggregate function performs a calculation on several values and returns a single value. We already know one aggregate function, count. We'll now learn 4 new aggregate functions, allowing us to find the average, sum, minimum, and maximum of a specified field. Let's look at some examples of how they work. These aggregate functions come after select, exactly like count. This first query gives us the average value from the budget field of the films table. That's an average of over 39 million per film in the films table. The sum function returns the result of adding the values in the budget field. Here, the total budget of all the films is over 181 billion. The min function returns the lowest budget, and the max function returns the highest budget. The 2006 South Korean movie, The Host, had a budget of over 12 billion. That sounds huge, but our data is in multiple currencies, so a true comparison would require currency exchange rates as well. Note that we operate on the field or column with all of these aggregate functions, not the records or rows. Although these functions appear to be mathematical, we can use several of them with both numerical and non-numerical fields. Average and sum are the two aggregate functions we can only use on numerical fields since they require arithmetic. We can use count, minimum, and maximum with non-numerical fields, as we already saw with count in previous lessons. Count can provide a total of any non-missing or not null records in a field regardless of their type. Similarly, minimum and maximum will give the record that is figuratively the lowest or highest. Lowest can mean the letter A when dealing with strings, or the earliest date when dealing with dates. And of course, with numbers, it is the highest or the lowest number. Here are some examples of using these functions with non-numerical fields. We can select the minimum and maximum country from the film's database and see that our minimum country, or country that would come first in the alphabet, is Afghanistan. In contrast, West Germany is the maximum country that would come last in the alphabet. Our database does not contain any films made in Zambia or Zimbabwe, but it does have at least one film made back when Germany was two different countries. Notice how all query results have automatically updated the field name to the function, in this case, min. It's best practice to use an alias when summarizing data, so that our results are clear to anyone reading our code. That's it. Let's get on to practice.
I think I'll just take a break. I'll be back after. I'll just eat my, what do you call this? I'll have a snack of my own. Thank you so much for staying with me, and I'll be back. Thank you. I have to end this for now. I'll be back later.